Good morning, everybody. This is Michael Fiebig with Fiebig Architecture. And today we're going to do a quick study on code requirements for acoustic performance under the International Building Code. So acoustics is kind of an interesting topic when you're talking about architecture and design. Acoustics obviously is we're dealing with sound and sound transmission and how that should be considered into the design and construction of your projects, of your buildings. And specifically, we're going to be looking at how this is regulated under the International Building Code. Specifically, we will not be talking about the International Residential Code. We're going to be limiting today's topic on the International Building Code. So let's first define what our scope of code required acoustic control is. Again, from the IBC, that's the International Building Code, we'll be reviewing the 2018 edition for this lesson. And that's going to be found in chapter 12 called Interior Environment, section 1206, Sound Transmission. And interestingly, this is actually one of the smaller sections in the code. The entirety of section 1206 is less than half of a code page. There's really not a lot to it, but it does happen to be very important. Acoustic privacy, acoustic separation. These are important topics that a lot of people care about, especially if you live in multifamily construction, like an apartment or a condominium. You're going to be interested in what is required for sound transmission. So here's the scope of the code regulations here. Section 1201.6 says, this section shall apply to common interior walls, partitions, and floor ceiling assemblies between adjacent dwelling units and sleeping units, or between dwelling units and sleeping units and adjacent public areas, such as halls, corridors, stairways, or service areas. So the first kind of important thing you'll notice here is that we're really limited into residential capacity here, dwelling units and sleeping units. You have to provide sound control or acoustic control between adjoining units. So if you have if you live in an apartment or a condo, you know you've got walls that you share with your neighbors, right? You have the common interior wall that separates your home from theirs. That would be an example of a wall that would need some acoustic control considerations designed and built in. This also relates to floor ceiling assemblies. So that's where, if you imagine you've got neighbors above you or neighbors below you, you want to have some sound control between the units above and the units below. So that would be the common floor ceiling assemblies. Now, one thing you'll notice here is that the term dwelling unit and sleeping unit, those are in italics. And whenever you're in the code and you see these terms in italics, that means it's a defined term. And so you can go to chapter 2 of the code to see these defined terms, specifically what they are. And we're going to do that in just a second for the term, for the code defined terms, dwelling unit and sleeping unit. But the idea here is that it's really limited to dwelling unit and sleeping unit separations. So it's residential capacities where you essentially don't want your loud neighbors to be bothering you, be it through the wall or from the floor above. So let's see. Yes, dwelling unit. Defined as a single unit providing complete independent living facilities for one or more persons, including permanent provisions for living, sleeping, eating, cooking, and sanitation. So that's, I think we all understand what a dwelling unit is. It's like somebody's home. It's where you live. It's where you live. It's where you eat. It's where you cook. It's where you bathe. It's where you sleep. That's a dwelling unit. A sleeping unit is, you can think about a sleeping unit kind of like a watered down dwelling unit. The term is defined as a single unit that provides rooms or spaces for one or more persons, includes permanent provisions for sleeping, and can include provisions for living, eating, and either sanitation or kitchen facilities, but not both. Such rooms and spaces that are also part of a dwelling unit are not sleeping units. So think about like a studio apartment with a communal kitchen or something like that. Like we don't see that as much nowadays as used to be the case. But something like that, or think about like in a nursing home or an institutional type occupancy, or even like a hospital where you've got patient rooms, but there's no kitchens, and you're not really intended to be preparing food in rooms like that. That would be considered a sleeping unit. Think about like motels with very small rooms, like little studio hotel rooms or motel rooms, where there may not be a kitchen in each unit. You may just you open the door and there's a bed and a small toilet room. Like you may have that. That would be considered a sleeping unit. So they are residential in nature, of course, because they are intended for people to sleep, be it both in a dwelling and in a sleeping unit. But again, the scope of required acoustic control really is limited to applications such as this. You don't have to do sound control by code. You don't have to do sound control for like commercial, like a mall building or a restaurant or other types of occupancies. Don't have this requirement. Per code, it's going to be dwelling units and sleeping units. So there's two types of sound control required. The first one is measured by STC. That's the sound transmission class. That's going to be measuring the airborne sound. That's things such as loud music, talking, laughing, TV, etc. That's airborne sound. That's just vibrations through the air, and that's measured by a STC, sound transmission class. The other one is IIC, which is impact insulation class, and that measures structure-borne sound. So structure-borne sound is going to be things like stomping your feet, dropping something on the floor, moving furniture, things that are actually causing the structure to vibrate, and that's structure-borne sound. So that's IIC. So these are the two types of sound control that are regulated by the code. First, let's talk about airborne sound. So here's what the code says: walls, partitions, and floor ceiling assemblies separating dwelling units and sleeping units from each other or from public or service areas. So let's stop there. So we did talk a little bit about the common walls that separate dwellings. Note the other part of this where it talks about separating each other, but also from public spaces or service areas. So that would be something like a corridor. If you're in like a condominium building with corridors going down the hall, where each unit has, the main entrance is in the corridor, you have to have sound rated assemblies separating the dwelling from the corridor. Or public areas such as like gaming rooms or meeting spaces, like if you're in a hotel and you've got one of the hotel rooms right next to one of the ballrooms, well, that would be considered a public area, and you'd need sound control between the dwelling and that ballroom area. So just keep that in mind. It's not just dwelling separation, but it's also the separation between those dwellings and public or service areas. So airborne sound, it says, shall have a sound transmission class of not less than 50 or not less than 45 if field tested for airborne noise, where tested in accordance with ASTM E90. So the code minimum here is 50. So you need an STC rating of 50 minimum, and that's like a lab test. So that's, if you're an architect or a designer, that's your minimum target, is you got to find or specify an assembly that hits that minimum 50. Now, the code recognizes that lab tested acoustic performance versus acoustic performance in the field are different. And that's because lab conditions are fully controlled. Field conditions aren't always fully controlled, right? Because you can't control what goes on in the corridor outside. You can't control what happens in your neighbor's unit above or beside you. So there's a little bit less control there. And so the code gives you essentially a 10% tolerance to meet that code minimum. If you design it to STC 50, and then if in the field you test it and it hits only 45, that would be compliant with this code minimum in this regard. Strictly, as a code minimum. And it also says, alternatively, the sound transmission class of walls, partitions, and floor ceiling assemblies shall be established by engineering analysis based on a comparison of walls, partitions, and floor ceiling assemblies having sound transmission class ratings as determined by the test procedures set forth in ASTM E90. So that's basically saying you don't have to just spec a system that's already been tested. If you're qualified and you can do the analysis, or if you can hire somebody to do the analysis for you, as long as you ultimately comply with those the 50 lab or 45 field tested, as long as you're following the same ASTM standard, then that's okay. The next sentence is also very important when it comes to designing construction of these assemblies that are required to provide acoustic control. It says, penetrations or openings in construction assemblies for piping, electrical devices, recessed cabinets, bathtubs, soffits, or heating, ventilating, or exhaust ducts shall be sealed, lined, insulated, or otherwise treated to maintain the required ratings. So that's going to be things like outlet boxes or light switches, or penetrations for electrical or utilities if they're like behind a cabinet or something. And of course, any heating or ventilating ducts, they all have to be treated to help maintain that required rating. And there's lots of products out there that can do this. But that's important to remember. If you're a designer, keep that in mind as well, that if you have to detail those things, make sure that you detail them in a way that maintains the required rating, or at least will comply with the listings under which those assemblies were tested. Lastly, notably, it says this requirement shall not apply to entrance doors. However, such doors shall be tight fitting to the frame and sill. So ASTM E90, that's the standard test method for laboratory measurement of airborne sound transmission loss of building partitions and elements. So that's the standard that you have to comply with to hit that minimum STC 50 in this regard. So here's an example of a tested assembly. This is from the Gypsum Association's Fire Resistance Design Manual. You see what we're looking at here is a wall detail comprised of double layer gypsum board and staggered wood studs. And if you look at the upper right part of this detail, you see it's got a fire rating, but you also see it's got a sound rating. That it says 50 to 54 STC sound. Then if you look at the lower right, you see the sound test. So this assembly was constructed and tested to result in a range of 50 to 54 STC. So if your goal is to hit that code minimum, then an assembly like this would do the trick, because it does hit that minimum 50 from a spec'd assembly. But let's keep this in mind too. Let's discuss minimum standards versus acceptable or preferred. So the International Code Council, that's the ICC, they've published a guideline for acoustics. That's called the G2 2010. And in this guideline, it notes very specifically that STC 50 that we were talking about, that really is a minimum. And when it comes to complying with the code, a lot of times architects and engineers and contractors, they aim for the minimum. And in many cases, that's probably fine. Like you saw in that detail we were just looking at, it had a 2-hour rating. If by code you have to provide a 2-hour rated assembly, that's the minimum, but that's also perfectly acceptable. When it comes to acoustics, we need to really understand that the minimum standard is what you would call like a D minus. It is the minimum acceptable. It's not even acceptable. It's the minimum standard. This guideline for acoustics provides some additional guidance here. Again, keeping in mind that the 50 target is the absolute minimum. This guideline for acoustics provides a couple of additional guidelines. One of them they call acceptable performance, which is called grade B. So if you want grade B, something that would be considered acceptable by most occupants, then for airborne sound, that's the STC per ASTM E90, you want to get 55, right? Or if you want a preferred performance, which would be considered grade A, you're going to aim for 60 STC. And it's very important if you're an architect and you're designing multifamily buildings, if it's apartments or condos or whatever, keep in mind what is the expectation, both from the client and the ultimate user of this particular building. Is it a bare budget economy level apartment where budget is very important and we really are just aiming for minimum? Then maybe STC 50 will do the trick. Is this a mid-level or upper level? Like if you're designing a luxury condominium or luxury apartments, you might want to think twice about whether or not STC 50 is enough. Again, keep in mind that STC 50 is the minimum. Acceptable would be 55, preferred would be 60. So in this case, I think the important fact to remember is that minimum STC 50, that's the bare minimum target. Don't make that your, don't think that if you hit that's all well and good and you don't need any other considerations. There may be other considerations involved that would require you to design to either a grade B or grade A level, especially if you're designing, like I said, high-end residences, like luxury level dwellings. You probably want to give them more than the code minimum in this regard, because that wouldn't even be considered acceptable according to the ICC. So let's talk about structure-borne sound. Again, from the 2018 IBC, this is very similar as far as what's required to STC. And here's what it says. Floor ceiling assemblies between dwelling units and sleeping units, or between dwelling unit or sleeping unit and a public or service area within the structure shall have an impact insulation class, that's the IIC, rating of not less than 50 or not less than 45 if field tested, where tested in accordance with ASTM E492. So we have the same standard here. The minimum is 50, that's spec'd from a lab test, or 45 if field tested. And of course, you have the alternative to engineer it. If you can do an engineering analysis, then that may be acceptable to the building department. And ASTM E492 is the standard test method for laboratory measurement of impact sound transmission through floor ceiling assemblies using the tapping machine. So we'll get into that a little bit further along in this lesson. So again, from the Gypsum Association Fire Resistance Design Manual, there's a little description about impact noise and the IIC classification of a floor. And again, here's an example detail just to look at. This particular detail, if you look on the upper, first of all, this is a floor ceiling. So what you're looking at here are I-joists with a structural floor above, and then you've got a drywall ceiling below. Very basic, very standard. It doesn't do a whole lot for sound. As you can see, it's only a 45 to 49 STC. So this is an assembly that's not even going to meet minimum code for current code. This would be kind of an example of an assembly that predates modern standards. So 45 to 49 is no longer meeting a code minimum. So if you're going to use this for a residential floor, you need to really think about it or alter it or do something else to it so that you actually can increase that STC. But specifically in this case, we're looking at the IIC. And if you look at the bottom part of this detail, you'll see it's got a little IIC and test. And then you look to the right and you see that it only has a 40 on the IIC. So this particular type of assembly doesn't really have much to offer as it relates to impact insulation. But just so you know, that's where you would find it. So if you are looking for an assembly that meets that minimum or above for IIC, that's where you're going to find it, at least in the Gypsum Association's handbook that we're looking at right here. Of course, other systems, UL and other manufacturers, they do provide different tests and different IIC classifications. So you just want to make sure that you spec one that complies with both the code and your intent as a designer. So let's look at the same guideline for acoustics from the IIC. You see that the bottom part of this table has impact sound. That's the IIC per ASTM E492. So once again, the minimum here is 50. That's the bare bones. That's the D- of design and the D- of construction. It's minimally acceptable, barely passes. Acceptable is 55, preferred is 60. So again, keep that in mind. If you're designing acoustic separations, you need to establish whether or not you're aiming for the minimum, if you're aiming for acceptable level, or if you're aiming for preferred for the grade A performance. So here's an example of one of those tapping machines. This would be a field test to measure the impact insulation of a floor in a multifamily building. So you can see this particular picture. We've got a tapping machine set up on the floor above, and there are microphones below to help capture the sound transmission. So let's take a look at what this looks like in action. So there you have it. I mean, it's a very interesting machine, but it's also very simple. I mean, all it's really doing is just shooting hammers into the floor to tap it at a controlled rate and controlled force. And then you measure that sound as it comes through on the other side. So with that being said, that concludes this lesson on acoustic performance. And I hope that this was an interesting and insightful lesson for all you architects, engineers, and contractors out there. If you have any questions, you can always reach out to us from our website. It's fiebigarch.com, or you can email us at info@fiebigarch.com. We're always happy to help on any design or construction project where you may have some questions that we may be able to help on. So thank you very much, everybody, and I hope you have a great day.